Hi, this is Rupesh, Assistant Professor from BVRAT Hyderabad College of Engineering, Foreman. Today, here we are going to discuss about the subject power system operation and control. So the name itself is telling that how we are going to operate the power system, and according to the utilization or according to the load incremental or any problems occurred in the power system, how we are going to control the power system. So these 2 points we are going to discuss in this particular subject. So to discuss in these 2 points, how many ways we are having to control the power system. So all these points are going to discussed about in this particular subject. So coming to the unit 1, in this particular subject we are going to discuss only about the load and frequency control. That means according to the load variation, how these frequency is varying, and to maintain the frequency as constant, how we are using the control mechanism in this particular chapter, right? So coming to the introduction, so before going with the introduction of this low frequency control, first we need to identify the main point that the frequency has to be maintained as constant. So just we are identifying that point as, that is, frequency need to be maintained as constant. So why we need to maintain this frequency as constant? So before going why, so we should know that what is the frequency and how it is related with respect to the generation as well as the speed. So here in India, the power generation is mainly depending on the thermal generation, right? So whenever we are depending on the thermal generation, we have to concentrate which type of machines are used in the thermal generating station. So in this thermal generation, synchronous generators or alternators are mainly used. So whenever we are talking about the synchronous generator rotates with respect to synchronous speed. So if we are trying to link the parameters which are present in this particular synchronous speed or synchronous generator, so that synchronous speed ns is equal to 120 f by p. So whereas f is equal to frequency and p is equal to number of poles. Once the alternator or synchronous generator is manufactured, means the number of poles are constant. Suppose if it is 2-pole machine, always the machine will be having only 2 poles. If it is 4-pole machine, once it is manufactured, means it will be having always 4 poles in itself. So that means p is a constant value. Again, 120 is also a constant value. So what I can do now, so this is a constant value and this is also a constant value. That means ns is directly proportional to frequency value. Ns is directly proportional to frequency value. That means whenever the synchronous speed or the speed of the synchronous generator or any machine is varying, means obviously the frequency of that particular machine will vary. So we have to see that the synchronous speed or the speed of that particular machine should be maintained as constant to maintain the frequency as constant. So why we need to maintain this frequency as constant? So one of the application is electric clock. Just we are trying to explaining the concept with respect to the examples. First example I am taking is electric clocks. That means electric clock, the name itself is telling that it is taking an electrical input and giving a mechanical output. So which machine will take electrical input and gives mechanical output? It is a motor. Here we are going to use synchronous motor. So the name itself is saying that synchronous, that means it is rotating with respect to synchronous speed. The synchronous speed is 120 f by p. According to the number of poles placed in that particular machine, gives the speed or gives the frequency. So suppose if it is rotating with respect to synchronous speed, according to that synchronous speed, it gives 60 seconds in a 1 minute, 60 seconds in a 1 minute in this particular synchronous motor. Suppose the frequency decreases. Whenever the frequency decreases, what happens to the speed? Speed also decreases. So instead of showing 60 seconds in a 1 minute, it may show 65 seconds in a 1 minute, which may not acceptable, right? So frequency, according to the frequency, the number of seconds will vary. in this particular example, electric lock. If the frequency increases, speed also will increase. So instead of 60 seconds in 1 minute, it may show only 55 seconds. So which will not be acceptable because it may affect the number of hours in a day. So it will lead to a great problem. So that is the reason we need to maintain the frequency as constant. This is first example. Second example, as already we discussed that India is mainly depending on the thermal generating station. So the turbines which we are used in thermal generating station mainly accepts the constant frequency plus or minus some tolerance value. The tolerance value is only 5%. So in theoretically we tell that 5%, that is 50 plus or minus 5%. So 5% means the value is 2.5 hertz, but practically it is not tolerable. So the tolerable frequency is 49 hertz to 50.5 hertz only. 49 hertz to 50.5 hertz only. So as per the theoretical knowledge, we say that it can be acceptable 47.5 to 52.5, but it is not accepting that frequency range. It accepts only 49 hertz. Lower frequency is 49 hertz and upper frequency is 50.5 hertz, right? So what happens if the frequency is below the 49 hertz or above the 50.5 hertz? So the turbine blades will be hit by the stream which is coming as input to that particular blades. So it will, the steam will be hitting the blades of the turbine at particular point if it is maintaining a 50 hertz of frequency. If it is beyond this value or 49, less than 49 value or higher than the 50.5 hertz of frequency, this steam will be hitting the other place of the turbine blades, so which may create damage to that particular turbine blades. So to operate the turbines in safe mode, we have to maintain the frequency as constant. This is the second example. Third one. So if we are in this example, we are taking constant synchronous motor. The name itself is constant voltage synchronous motor. That means voltage need to be maintained as constant. I know that induced EMF in generator EG is equal to 5 ZNP by 60A. 5 ZNP by 60A. 5 may be varying. Z, number of conductors in alternator or generator, is constant once it is manufactured. N is varying, whereas I already know that Ns is directly proportional to F. So in place of N, I am writing F, and 5 Zn P, number of poles, is constant, by 60 is a constant, and A is also a constant. So it mainly depends on E is directly proportional to phi into N, where N is directly proportional to frequency. So I can write E is directly proportional to flux and frequency. Here, if I am trying to write the equation for flux, E is equal to E by F. And again here I am taking the constant voltage synchronous motor. That means E is a constant value. So flux is inversely proportional to frequency. That means whereas frequency increases, flux decreases. Frequency decreases, flux increases. So you assume that frequency is decreased, flux will be increasing. But flux value mainly depends on that core value, right? So if flux increases, core will be saturated. That means due to incremental of flux, the core value will not be operating in proper manner. So it will get damaged. It may get damaged. That is the reason we need to maintain the frequency as a constant, right? So going to the next example. So we'll be taking a transmission line, right? So transmission line, power will be transmitted from generating station to any transmission substation. So whenever power is transmitted, the frequency need to be maintained as constant, because the power will be transferred through a transformer, right? Transformer is a constant power electrical device. Whenever power is transferred with respect to either increased amount of frequency or decreased amount of frequency, heat will be generated, right? So whenever heat generated, the amount of power will be wasted in terms of heat loss, so that efficiency of the transmission line will get reduced. This is the first disadvantage. Second one, the transformer winding will be get heated due to the heat generated in the transformer. The transformer winding in the transformer is overheated, which may lead to damage of the transformer winding also. These are the two disadvantages in the transmission line, right? Coming to the next example, the most serious effect of subnormal frequencies on the operation of thermal power plant. Again, we are going with the thermal plants itself. If the frequency is reduced, when the frequency is reduced, if the demand is increases, the frequency will come down. So whenever the frequency come down, ID and FD fans operation will be decreases. ID and FD fans operation decreases. As a result, decremental of the generation. Due to this decremental of the frequency, because EG is directly proportional to the speed is directly proportional to frequency, and output power is equal to 5 ZNP by, output power is equal to 2 pi NT by 60. Again, it depends on the torque value. So whenever the frequency decreases, the power generation will also come down. So there will be a mismatch of demand and generation. So if this is continuous for a longer time, there will be a great difference in between the demand as well as generation, which leads a complete shutdown of a plant, again which leads a blockout. So these are the disadvantages if we are not maintain the frequency as constant. That is the reason we need to maintain the frequency as constant, right? This is the point where we need to concentrate.